Here today is I just wanted to take your guys' questions that you might have. We are going to take the chapter 12 and 13 tests this week. So for you guys, that would be Thursday. Figured that was better than today. But that's the plan. So any kind of, we can do specific questions or clarification questions or kind of whatever you guys might need is fine. Anthony? Sure. Do you have one in mind that you would like to do? Well, 22 is not a long division problem. I would use synthetic on that. I can't hear you.
I would put, are you going to put long division on the test, because it's just going to be synthetic?
It could certainly have long division on the test. So Anthony, 16, 17, or 18, I think, are all long division problems. 18, you say? Okay. So the setup for one of these long division problems, the denominator is your divisor and the numerator is your dividend. Notice in the numerator how we go from x cubed to x's and we skip the x squareds. I'm going to include the x squareds because it just keeps everything lined up. Now, as long as you're combining like terms correctly, you don't need to have that 0x squared there, but I do it every single time because I think it helps keep everything a little bit neater and more organized. But it's not a disaster if you forget it. So what I'm going to ask myself is, what times 2x gives me x cubed? So let's do the coefficient part first. 1/2 times 2 is going to give me 1. And then let's do the x part next. So x squared times x gives me x to the third. Oops. Cool with that? So then I'm going to multiply this to... So this times this needs to give me that. So 1/2 times 2 is going to give me the coefficient 1. And then x squared times x is going to give me x to the third. So I'm just doing variable part or coefficient and then variable. So I multiply then to the entire divisor. So it's going to give me x cubed minus 2x squared. And then I subtract down. So x cubed minus x cubed is 0. And 0 minus a negative 2x squared is 2x squared. And then I bring my next number down. 1/2 times negative 4 is negative 2. Is that? Okay. So now we're going to just start over. So I'm going to say, what times 2x gives me 2x squared? Well, that's x. And then I multiply that to the entire divisor. So 2x squared minus 4x. And then subtract down. 2x squared minus 2x squared is 0. Negative 7x minus a negative 4x is negative 3x. And then I bring the 1 down. And then my last step is going to be, what times 2x gives me negative 3x? Well, that's going to be negative 3 over 2. right?
Yeah.
Okay. So I distribute that. So I have negative 3x plus 6. And then subtract down. So negative 3x minus a negative 3x is 0. 1 minus 6 is negative 5. And then to meet the criteria of the problem, it asks us to write in the form, our answer in the form of quotient, which is this, plus remainder, which is this, over the divisor, which is that. So this would be the properly formatted final answer. Is that okay?
Yeah.
Sure. Tyler.
Number 50.
50? And this stuff is all from chapter 13 I'm taking, right?
Yes.
Yeah.
Okay.
I didn't know how to do it.
Okay. So what did you try to do for this problem?
I don't even remember.
So I would,
I knew I couldn't do like I was screwing up.
so I would do this just by factoring because there's no reason to do any synthetic division on this problem because this is something that I can factor quite easily. So what I would do is I would just say let y equals x squared. So now I have just like a quadratic. So it multiplies to give us negative 64 and adds to give us 12. 16 and negative 4, right? Oops. So far, so good? Everybody okay? Now let's put the x squared back in because we're not asking to find values for y. We want the zeros. We want values for x. I noticed that x squared plus 16 we can't factor anymore because it's the sum of two squares, not the difference. But x squared minus 4 I still can do a little bit more with. Right? And then if I want to find the zeros, I just then apply the zero product property and set each of these factors equal to 0. So that's going to give me plus or minus 4i, and then x equals 2, and x equals negative 2. And since none of those are repeated, they all have multiplicity 1, and that's it. I would do it that way without doing any synthetic divisions, because that to me feels much faster. I don't have to get my calculator out and look at a graph at any point. But you could have done it with synthetic division still. That's perfectly fine. Did I satisfy your question, Tyler? Do you have some follow-up here?
How about 52?
Okay, before I move on from this, Keaton, do you have a follow-up?
Yeah, I have 2 questions.
Sure.
One, how do you know to do it that way? Do you kind of just look at it?
Well, the fact that it has 3 terms,
Yeah.
and the degree of the leading term is twice the degree of the middle term,
Okay.
tells me that it's in the quadratic form. So I would first look to see if I can make it, like, can it factor like a quadratic? So that's what I was looking for there on that problem, how I knew to do that instantly. So you couldn't do that with any of the other ones on the list there because they all are not in that quadratic form, right? So there's no shortcut through on any of these other ones, it looks like. No, at least obvious shortcut.
Let's say you did do synthetic division.
On 50?
Yeah.
Okay.
Do you add a 0 for x cubed?
So I would start by looking at my possible rational zeros. So that's going to be the factors of 64 divided by the factors of 1. So the factors of 64 are 2, 4, 8, 16, 32, and 64. I would then go ahead and look at the graph of this function and look at the x-intercepts.
I believe it's -2.
What?
I think it's -2 and 2.
Yeah, I just wanted to show the graph to everybody of what I was looking at. But yes, you're right. Now, when I graph this, I would graph this from -64 to +64 because those are everything I could possibly see. Now, I'll likely have to zoom in. And then I'm just going to go from like -3 to +3 on the y's because all I care about is where it's crossing the x-axis. So if I hit graph, looks like all my action is going on right close. So I'm pretty positive that like all this stuff from 8 and above is garbage. It's not actually anything that I care about. So I'll just go from -4 to +4 now. So that's -2 and that's +2. And since those are actually on my list, they are good ones to do synthetic division with. I wouldn't want to do synthetic division with something from my graph that wasn't on that list of possible rational zeros, because it will not work. Synthetic division will not work if you don't have the exact value for it. So if you have like the square root of 3, you can't get the square root of 3 from the graph. And if you can't do the synthetic division with the square root of 3, if you just do like 1.6 or 1.7, it won't work. So let's say we do the synthetic division with -2. So I'm going to have 1 as my coefficient on the x to the fourths, 0 my coefficient on the x cubes, 12 my coefficient on the x squareds, 0 my coefficient on the x's, and then -64, which is my constant. So you have to have the zeros in for the synthetic divisions. If you forget the zeros, you will not get the right answer. There's no way to recover the right answer. Okay. The first step in synthetic division, we bring the first number down. Hi. Thanks. Taylor, it's for you. Then we're going to take the number on the outside, multiply the number underneath, and write it in the next empty spot, and then add down. And then just keep repeating that. So -2 times -2 is 4. Add down is 16. -2 times 16 is -32. Add down, that's -32. And then do it again, and we get 0. So I'm going to then take that result and synthetic divide with the next one. You could stop here even and factor that by grouping, but I'm going to continue with the synthetic division.
Is it easier to just do synthetic division?
Usually it's going to be to your advantage to do that because the factoring gets easier every time you do the synthetic division, and it's pretty quick and easy to do the synthetic division once you have it set up correctly. There are possible situations where you could synthetically divide something to a place where you can't factor it, but you could have factored more if you had stopped the synthetic division earlier. I don't think there's any situations like that that came up in this homework, but that's a possibility, particularly if you have things that involve like multiple sum or differences of cubes. Is places where, like, in particular that can happen, but I don't think that's going to happen for you guys anywhere in the homework. So what this tells you then is that -2 is a 0, +2 is a 0, because they both give you a remainder 0 when you do the synthetic division. Now you're going to look at the stuff that's left over. So this is the constant, the x coefficient, and the x squared coefficient. And you'll just solve the remaining piece, which is x squared plus 16. And that's where your plus or minus 4i is going to come out of. Trev, was that?
Yeah, that helps.
Okay. Did I call you the wrong name before?
Yeah.
Why didn't you stop me and be like, hey, that's my...
I'm used to it.
Oh. Well, you're entitled to be called the right name. So if I make a mistake, like, just tell me and I'll try to do better.
Sure.
Okay.
I just have a general question. So, back when you were factoring, if there was like a term in front of the y, like if it was like 2y squared,
Mhm.
do you multiply it by the 12 and the 64, or is it just the 12?
So for like ax squared plus bx plus c, if you want to factor this, you'd want the two numbers that multiply to give you ac and then add to give you b.
Okay.
I think is what you're asking me, right? Okay. You're welcome. Keat.
This is kind of just curiosity, but let's say on your graph you have 2 zeros, so like plus or minus 2 and plus or minus 5.
Okay.
Is that possible?
On your graph, that would be 4 separate things that you'd see.
Yeah.
Sure.
Okay.
So the degree of your polynomial
Yeah.
is going to be the maximum number of zeros that you can see on your graph.
Okay.
So if you have a degree 4 polynomial, you could see 4 x-intercepts. You could see less, but you can't see more.
You like mix and match the zeros versus like
The order in which you do the synthetic division does not matter.
so you could do like -2 and 5 if they're both 0.
Yes. Or you could do 5 and then -2. It doesn't matter the order in which you do them. You'll get the same result eventually. Like the numbers along the way in the synthetic division will be different, but the end result will give you the same. You'll get to the same spot. Josh.
I know it's more of the same, but could you do 51? I mostly just like the end of it. I just kind of wanted to know how to do that if you want to skip on the rest of it.
Well, it's okay. Let's just, it's good review for everybody else that has some issues with some of the other parts along the way.
Can I move back there and charge my tablet?
Absolutely. So again, my possible rational zeros are going to be factors of 2 divided by factors of 1. So just plus or minus 1 or plus or minus 2. I'll go take a look at the graph. So I have x to the 4th plus 4x to the 3rd. Oops. Plus 7x squared plus 6x plus 2. Okay, and this window will still be fine because it's going to cover all the way from -2 to +2. So I'm not going to bother changing it. It's good enough. So here's -2, there's -1. This looks like it's 1 x-intercept, but if that were the case, that's nothing for me to do on this problem because I can't factor it. My suspicion is if I zoom into this area a little bit more closely, there's going to be more than 1 x-intercept going on here. So that's what I'm going to do. So I'm going to adjust my window to go from -1 to 0, and then I'm going to adjust it down to go from like maybe -1/2 to +1/2 to get a better look at what's going on in there. Oh shoot, I forgot that my scale was screwy. Okay, let's leave that the way it was and just change the scale. I forgot that scale I left at 2. Let's look at one more time. Okay, so that looks like at -1. I'm sorry. I forgot that my scale was goofy. So from the graph, I see -1. Now, did you notice the way that x-intercept is happening? You see how it's hitting the x-axis and then bouncing back in the same direction? There's a rule for how many times those things can be used. So a bounce indicates that that x-intercept is going to be used an even number of times in my synthetic division. So like it'll be used 2 times or 4 times or 6 times. Okay with that?
Yeah. You can just use it again.
Yes. So again, like that's what a bounce looks like. So if you have an x-intercept that looks like that, it's going to be used at least twice. The other option is if you have something that's a bend, it'll be used an odd number of times greater than 1. So like this is a bend. So 3 times, 5 times, 7 times. You cannot use it twice. Just like with the bounces, they could not be used 3 times. 2 times or 4 times, but never 3.
So how do you know if it's going to be like 3 or 5 without doing?
You don't necessarily. So sometimes you can reason it out by what else is there, but sometimes you can't. So in this problem, we don't know if the -1 is going to be used 2 times or 4 times just by looking at it, right? It's a degree 4 polynomial. So there are 4 zeros. We don't know if there are going to be 4 -1s or if there's going to be some other stuff. Not yet, anyways. So let's start our synthetic division and find out. So it worked once, which we knew was going to happen. We'll try it again, because we know it's going to work at least 2 times. Worked again. Let's try it one more time. Oops. And it failed, right? It did not work. So what we'll do is we'll go back to this part, the last result we had when the division worked. So again, it's my constant, my x coefficient, and my x squared coefficient. And we'll set that part equal to 0 and solve. So that's not factorable. If it was, the synthetic division would have worked. So I'll use the quadratic formula. So 4 minus 8 is -4. So that's going to be -2 plus or minus 2i over 2, or that reduces all down to -1 plus or minus I. And then from up here we had x equals -1 multiplicity 2. Since we used that answer twice.
Okay.
Is that okay?
Quadratic formula on the test.
No, that would be a reasonable expectation for you to have memorized. Actually, I don't remember if it's on there or not. Look at the review. Whatever's on the review is on the test.
We don't have any
Just
questions.
zero. There's nothing.
Oh, okay then. Then that's a reasonable expectation to hit for you to still have memorized. So,
Can you go over again, just kind of how to find the possible rest zeros?
yeah,
How to go over that?
is that's the leading, or I'm sorry, factors of the constant term divided by factors of the leading coefficient, positive or negative.
And that's for what?
The possible rational zeros. So that's just if the, so for example, if we have like 4x squared plus 6x plus, 15, my factors of the constant term are 1, 3, 5, and 15. And my factors of the leading coefficient are 1, 2, and 4. So my possible rational zeros are going to be 1 over 1, 3 over 1, 5 over 1, 15 over 1. And then 1 over 2, 3 over 2, 5 over 2, 15 over 2.
Need them all organized.
I mean, I usually write them just like whenever I find them. And then I have 1 over 4, 3 over 4, 5 over 4, 15 over 4. So does that feel okay?
Yeah. How do you know when it's like double? How do you just do it like?
So that I determine by looking at the graph.
So then after we find the possible rational zeros, we should probably graph it.
You should graph it. And then you're looking at the x-intercepts
Okay.
and looking for x-intercepts that appear on this list.
Okay.
So only the ones that appear on this list are the ones I care about. If it's not on this list, I'm not going to use it to do the division with. And the way I can tell if it's going to be used more than once is how that x-intercept looks. So like if it just goes straight through, that's one time. This is a straight, what we call a straight. If it hits the x-axis and then goes back the way it goes, yep, this is a bounce. It's called a bounce. This is used an even number of times, so 2 times, 4 times, 6 times. And the other possibility is we have something like, this. This is called a bend. And this would be used an odd number of times, so 3, 5, 7, etc. Is that okay, Soph?
Yeah. How do you find the x-intercepts again?
You just look at the picture.
Richard Lynn is this. Like on your calculator.
Yeah, you're just estimating. Shirley.
When you scroll up, when you have a question about the problem,
Yeah.
farther up.
Okay. Yes, go ahead, Josh.
How do you, or like what determines if the synthetic division steps?
Oh, so we need a remainder 0.
Oh,
If you don't get a remainder 0, then it didn't work.
and since you didn't get a remaining zero,
That's why I stopped and went back to the previous solution and picked up from there. Does that feel okay? Cool. How's this? Is this helping to kind of plug some holes? What's up, Trev?
That's what we just did, yeah. No, that's not finding the so say you wanted to get the remainder 0, your final answer would just be the final number you have.
No. So you're.
So say that -1 was -2 and your vector 0, you just keep going.
Well, at that point, you know that since it was a bounce in this problem, that you're just going to have -1 multiplicity 4, because it's going to be used either 2 times or 4 times. If it works 3 times, it could only be 4 then, so you could just be done and not even do another synthetic division. If you did, though, you'd have 1 remainder 0. I think is what it would say. So you'd have like 1 as your factor. So I think there'd be a 1 there, but the remainder 0 still at the end. Yeah. Trev, did you?
I figured it out.
Okay. Do you want it? Okay. What's up?
How about 14 on the
from chapter 13.
14 from 13.
Yes.
Okay. So it says find a cubic function in standard form with the given zeros. So we have x equals square root of 5, negative square root of 5, and 1. So my plan here is I'm going to convert each of these zeros into a factor. I can do that by just subtracting to putting everything on one side, I guess I should say. Okay with that?
Yeah.
Now what I'm going to do is I'm going to multiply all these equations together. So when I do that, I get x minus square root of 5 times x plus the square root of 5 times negative 1 equal to 0 times 0 times 0, which is still just 0. Cool there. Now I'm just going to FOIL this stuff out. So I'm going to multiply these together first because I notice that's a difference of 2 squares. So that's just going to be x squared minus 5. Is that okay?
Yeah.
And then I'll FOIL out this stuff. So that's going to give me x cubed minus x squared minus 5x plus 5 equals 0. But I guess I don't need the equal 0 anymore because that's my cubic. Keith.
When you say find all zeros, are you looking for every zero?
Real and imaginary.
Well, like, do you want the whole big list, or do you just want the ones that are there? That you
So
find?
the big list is the possible rational zeros. When I say find all the zeros, I mean the actual zeros for that function. So the possible just means that, like, hey, just by looking at the equation, I know that these are the possible rational zeros.
Okay.
I don't know anything about the irrational things or the imaginary things,
All right.
or even that any of these are actually going to be zeros for my function. If I say find all the zeros, I want the actual values.
Just graph to figure out which ones are actually. Yeah.
Well, you could find the real ones that way. You will not be able to find the imaginary ones that way.
How do you find the imaginary one?
You have to do the synthetic division process.
Okay.
You will not be able to find them any other way. What do you guys think? You want to talk about some more? I'm happy to do some more. We have time still, right? We're here till 11:20, so you have 30 more minutes. I'm happy to field more questions, or I can buzz off and let you guys do stuff on your own. You tell me. Shirley.
You would do number 19.
19? Sure. So this is number 19 is another long division problem. So again, I'm going to set this up the same way. So the dividend is the denominator. I'm sorry, the divisor is the denominator and the dividend is the numerator. Notice that I don't have an x squared term, so I'm going to put a 0x squared in there. And even though that, and let's put a 0x squared here too. I'm going to do that also. Now, even though I got a lot of terms going on in my divisor, it really doesn't make this problem any more difficult. I'm still going to start it the same way. And I'm going to ask myself, what times x cubed gives me 4x to the fourth? Which would just be 4x squared, right? So I'll multiply that to my entire divisor. So I have 4x to the fifth plus 0x to the fourth plus 4x squared minus 4x to the third minus 20x squared. And then subtract down. So 4x to the fifth minus 4x to the fifth is 0. 7x to the fourth minus 0, 7x to the fourth. 1 minus 4 is negative 3x to the thirds. 0 minus a negative 20 is positive 20, x squareds. And then bring down the next term. And then repeat. So what times x cubed gives me 7x to the fourth? 7x, right? So plus 7x. Again, multiply that to everything. So I have 7x to the fourth plus 0x to the third plus 7x squared minus 35x. Subtract down. 7x to the fourth minus 7x to the fourth is 0. Negative 3 minus 0 is negative 3x to the third. 20 minus 7 is 13x squared. Negative 8 minus a negative 35 is positive 27x. And then bring that last piece down. And what times x cubed gives me negative 3x cubed? That's negative 3. And then multiply all that stuff. So negative 3x cubed plus 0x squared minus 3x plus 15. And subtract down. So 0, 13 minus 0 is 13x squared. 27 minus a negative 3 is 30x. And 1 minus a negative 15 is negative 14. So that's my remainder. So my answer is the quotient plus my remainder over my divisor.
You don't have to do anything with your full thing. You don't have to do anything else.
Correct. Yep. So even though the remainder contains more than isn't just one number, that's fine. It can have x's in it, no big deal. So the thing you have to remember, Alex, is that the degree of the remainder has to be less than the degree of the divisor. As long as that's the case, it can have as many x's in it as it wants. They just have to be less than the degree. Yep. And it should be fine. I mean, it doesn't mean that you didn't make a silly arithmetic mistake somewhere else on, but there's nothing wrong with, there's nothing more to keep going, is what I'm saying. So the other indicator here is once you've gotten to the constant term in your quotient, you're done dividing. Whatever's left after that point is just going to be remainder. And again, even though that one looked like it was long, it was really no more steps than the previous ones, right? Or at least the previous one is still 3 steps.
I also have a question on the review deck.
Sure, we can look at the review.
So, can you explain how to do the question 5 for absolute function, how to find the function that satisfies the conditions?
Sure. Let me just pop this in here. So you're talking about these ones? No.
Chapter 12.
Oh, chapter 12. Okay. Five. So this thing here?
Yeah, I was going over that.
Okay. So this is basically just, oops, 2 points, right? So wants a linear function from 2 points. To do that, I need a slope and a point. The slope in this case could be 10 minus 2 over negative 3 minus 9. Oops, that's not right. So negative 2/3. And then to find the answer, I'm going to take one of the 2 points. It doesn't matter, just for the sake of argument, let's take this one. So I say that 2 is equal to negative 2/3 times x plus b. So 2/3 times, or negative 2/3 times 9 is negative 6. And I add that 6 over and I get b is equal to 8.
I realized that was the point for some reason. I forgot.
Yep. Yep, so that's the trick, is just to think about them as points. Alternatively, you could do this in your calculator. You know, you could go to the stat, edit, and then just type in this point and this point, and then have it do a lin reg, and it'll spit out that answer. Is also fine. Okay. Well, I have one thing for you guys to do today.
I have more questions.
What?
I have more questions.
Where were your questions a minute ago?
You just woke up, so you said what you just said.
No, actually.
All right, what is it?
How's your
That's my first one.
how's your
Can you just go down to like the other question 6? And then, okay, wait, go back up. Like one more thing. Can you do like, what is it, letter like D? How do you do the leading coefficient?
So you want to do B, you said?
D.
D?
Or B, either one.
Okay,
Let's do B.
all right. So since I want real number coefficients, because I have an imaginary thing, I also have to have its conjugate. So 4i also needs to be on my list. So I'm going to have x plus 2, x plus 3, x plus 4i, and then x minus 4i. Okay with that? Okay, and to have a leading coefficient of 3, I'm just going to multiply the whole thing by negative 3.
Oh, okay.
Yep. So let's go ahead and FOIL this stuff out. So I'll FOIL these two things, or those two pairs first. And then I'll FOIL this. So I have x to the 4th, and then 5x to the 3rd, and then 16x, and 5x is 21x squared, and then 5 times 16 is 80, and then that's just 80x, and then 6 times 6 is, or 6 times 16 is 72. And then if I think that's right anyways. I might have goofed that up because I didn't write anything down, but I tried real hard to get that. And then multiply by the negative 3. And then 72 times 3 is 216. I think is right. Again, I might have goofed up that foiling out the x squared plus 5x plus 6 and x squared plus 16 because I didn't write anything down. To do it, I tried to do it all in my head, but I think it's right. Alex?
Why do you have to include the x plus 4i and the x minus 4i?
Because if you want real coefficients in your polynomial, you will not get them without the complex conjugate there. So if you did that with just negative 4i, when you FOIL that out, you're going to have i's in your coefficients, which means that you won't have real coefficients. Josh?
So for letter A there, you just take like those numbers and do x like minus 3.
And then you need a negative 3i.
Yeah, and then you just multiply those together.
So x minus 3, x minus 3i, x plus 3i.
Oh, when there's an I, you have to do both.
Yep.
Okay.
Same thing with a radical also. Like if you, do we have any with those? I guess not. Maybe are there some more down here?
Yeah, I didn't look at the review yet, so I didn't know that those were like problems.
Yeah.
I didn't know how to do that.
So the same thing would happen if you had like the square root of 3, that you'd also need like negative square root of 3.
Okay.
So the same thing works with, well, actually that would be fine for real coefficients. I shouldn't say, it'd be fine if you didn't have both of them. If this was rational coefficients, you would need the conjugates for your radicals.
Okay, thank you. And then I squared is just negative 1, right?
Correct. Yes.
Okay, cool.
That is correct.
Yeah. I think I'm right.
Okay. Sophia?
Question. It's just like a generalized question.
So scroll down.
Get that page.
Okay.
For it's asking for like the zeros, the extreme, and all that stuff. Do we have to do like algebra? Like find the zeros, extreme, like can we get
So find all the zeros and state the multiplicity. Because we're asking for exact, you'd have to do that algebraically.
Okay. And that's just the whole like possible rest zeros, like the okay.
You'd have to do that process to identify them.
So this is basically like the last two problems for
Mm-hmm.
okay.
Yeah, and I think even 7 is really still the same thing.
Okay, so basically
Yeah. I don't, let's see. 11:20.
How many questions is gonna be on the test?
I haven't, it's on my to-do list to write the test today.
Okay. Could you just maybe like put the test format like on the content library as or something?
Or I'll attach it to the assignment on the calendar.
Okay, yeah, that works. Thank you.
Yeah, I'll put it one of those two places.
Okay.
Yeah, sure. Reasonable question. Typically do that. A partner test? Get out of town.
Content library.
Anthony, what you got next?
Actually, it's from chapter 12. That's okay.
Yeah, that's fine.
I'm just confused with number 16 on the chapter 12.
Okay. Let's. Did I have the chapter 12 and so let's just read it. Okay. So 16 asks, do the following represent functions? Yes or no? Oh, power functions, yes or no. And then to, if not, or if so, state blah, 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 and blah, blah, blah. So the trick here is the x in the denominator. Oops, that's not what I wanted to do. So this was k over x. So k over x is really k times x to the negative 1, right?
Of course.
So in that case, then, this is in the form of a power function because you have y equals ax to the b, right? So the degree is negative 1. Yep, that's the power. And your constant of variation is k. You're welcome. So that was the trick, is remembering that you can rewrite something in the denominator with a negative exponent. Yep. Yes. No! You still have 12 minutes. You booger.
How long are we meant to have? It's 15 done the same way.
15? Probably. Oh no, so that one's just not a power function. Because the variable isn't the base of the exponential, the variable's in the exponent. So that one's just no, it's not a power function. Yes. Oh, we got like 12 more minutes here, folks. Yeah, that's what this time is for,
So
man.
it's like on that same homework, just, you can do like 1 of 18 through 20, right? That just not
Okay.
confuses.
So the volume of a cone with constant height varies directly with the square of the radius of the base. So the volume of a cone is equal to the constant height varies directly with the square of the radius of the base.
Oh, so that would just be it.
Yeah. I mean, I think in the answer key I wrote it with K instead of H, but like, who cares? It's just a letter.
Oh, like that.
Yeah. There's really nothing to it. It's just like decoding the language.
Yeah. Yeah.
Yeah, no problem. Sometimes you just need to talk it through, right? Sure. So the measure of an angle of a right triangle varies inversely with the length of an adjacent leg. Okay? So we have some constant, and because it says varies inversely, are we multiplying or dividing? Dividing. So L for leg. So the other one, because it varies, directly, it's multiplication. If it's inversely, it's division. But that's the gist of it. Yeah, and this is still a power function, right? Because this is y equals k times L to the negative 1. Yep. Yeah, and you could write it that way if you wanted to also. That's fine.